Newton's method uses tangent lines to approximate the graph of a function near its x-intercept. To approximate the zeros of a function, we must let f of c equal 0, where f is differentiable on an open interval containing c. Then, to approximate c, we use the following steps. Step 1, make an initial estimate, x1, that is close to c. Determine a new approximation using this formula. 3, if the absolute value of xn minus xn plus 1 is within the desired accuracy, let xn plus 1 serve as the final approximation. Otherwise, return to step 2 and calculate a new approximation. Each successive application of this is called an iteration. Now we're going to solve this problem, x to the 5th minus 2x to the 3rd plus x minus 4, using Newton's method. You're going to need a calculator, something handy-dandy like this. The first step to solving this problem with Newton's method is you must make a chart. Your chart must include n, xn, f of xn, f prime of xn, f of xn divided by f prime of xn, xn minus f of x over x prime of xn. By looking at the graph, we can see that the x-interception is 0.161. So to use Newton's method, we're going to pick a point close to this, let's say 1.8. Second, we identify our initial point in our graph. Third, we find the derivative of this function, which is 5x to the 4th minus 6x squared plus 1. Now we plug 1.8 into the original function, and we get 5.03168. Now we plug 1.8 into the derivative, and we get 34.048. Now we take our original function and divide it by the derivative, and we get 0.147782. Now we record x1 minus the original function divided by the derivative, and we get 1.6522. We're now going to take another iteration to see if we can get closer. So our second n will be 1.6522. We plug this number into the original equation, and we get 0.94392. Plug this number into the derivative, and we get 218808. When we take the original function divided by the derivative, we get 0.043139. Take x2 minus the original function divided by the derivative, we get 1.60908. There is no need to take a third iteration because 1.60908 is close to the actual zero of the function, which is 1.61.